You have been using objects and classes in your previous work in this course. Now you will learn how to implement a class, that is, how to write code inside a class definition. Before we talk about the inside of a class definition, let's quickly review the outside view of it that you have been using all along. You can think of a class as a type, which means that it is a blueprint for making instances, that is, objects, of that type. As such, the definition of a class specifies three things. First, the name of the class. As a matter of style, we always begin the name of classes that we define with an uppercase letter, like the capital P of the point class. Every other name begins with a lowercase letter, like a little p. That helps us distinguish class names from other names. Second, the instance variables of the class. These are the names that the class uses for the data that instances of the class store. For example, a circle class has instance variables radius and center. That means that an instance of the circle class, that is, one particular circle, stores, that is, knows, its radius and its center, and that we can refer to those values using the names radius, radius, and center, center. We use the dot notation with instance variables to distinguish names of instance variables from names that are not associated with an object. Third, the methods of the class. These are the names that the class uses for the functions that instances of the class perform on their data and any arguments given to the methods. That is, methods are things that an instance of the class can do. Corresponding to those three parts of the definition of a class is the notation that you have been using all along for using those parts. That is, first, you have constructed objects by using the notation name of class, parentheses, and any information that the instance of the class needs when it is constructed inside those parentheses. So in this example, the name P1 refers to the instance of the point class, that is, the object whose x and y coordinates are 70 and 20, and the name P2 refers to the different instance of the point class whose x and y coordinates are 55 and 90. Second, you have referenced those values of the data associated with an instance of a class using the dot notation and the names of the class's instance variables. So in this example, the code computes what is called the dot product of 2 points by using the notation for each instance variable of each object, name of the object, followed by a dot, followed by the name of the relevant instance variable of the class to which the object belongs. So in this example, p1.x is the notation to refer to p1's instance variable x, which has the value 70, and p2.x is the notation to refer to p2's instance variable x, which has the value 55. By the way, I am using names for my variable that are not as descriptive as good names should be, and I am doing illegal line breaks for those to make the examples fit on the slide. It is critical to note that since P1 and P2 are both instances of the same class, point, both P1 and P2 have the same name associated with them for the value of their x-coordinates, namely the name x. But P1.x means P1's x value, and P2.x means P2's x value. Same names for the instance variables, but different values for them when they are associated with different objects. Another example, all circle objects share the name radius, radius, as the name of its radius, but each circle has its own value for its radius instance variable. So far, we have reviewed how you construct an object and how you refer to the data the object stores by using its instance variables. The final item in our trio is, third, you can make an instance of a class do something by calling a method of the class on the instance. For example, if we have an instance C1 of the circle class and an instance of the rose window class called window, then we can attach the circle to the window using the circle's attach to method. The notation is exactly like the notation for referring to an instance variable, except the name after the dot has parentheses. Also, the notation is exactly like calling a function, except the name has an object and a dot in front of the name. By the way, note that to attach a circle to a rose window, the attach to function needs both the circle and the rose window. The designer of the circle and window classes felt that it was more natural to say circle, attach yourself to that rose window, than rose window, attach that circle to yourself. That is why the attach to method is defined in the circle class instead of the rose window class. It could have been done the other way. It is up to the designer of the class, which is what we are turning to now. But before we do so, again, keep firmly in mind what you already know. 1. What it means to construct an instance of a class, and the notation for doing so. 2. Given an instance of a class, that is, an object, what it means to refer to the instance variables of that class, and the notation for doing so. 3. Given an instance of a class, that is, an object, what it means to call a method on that object, sending arguments to that method, and the notation for doing so.